out the voltage drop across this resistance R. But you know that this resistance R is connected in series with RL, right? R is connected in series with RL. Okay. Do you know about the series connection? Can you say? The series connection, what is series connection? See, if we are having two resistors, R1 and another resistance, R2, then what is series connection? One leg of the resistor R1 is connected to the leg of the resistor R2. Okay. So, if these resistors are connected in this way, then we can say that this is the series connection. Okay. In the case of series connection, whenever we are applying a current or if we are giving a current to this series combination, what is its nature? The current through a series combination will be same. Okay. So, the current will be same in the series connection. Current will be same. Okay. Current will be same in the case of series connection. Similarly, if you are connecting resistors in parallel, what is parallel connection? How can you connect two resistors in parallel? See, there are two resistors, R1 and another resistor, R2. How can we connect it in parallel? How can we connect it? Anybody say? Anybody can say? Anybody have answer? Parallel connection means that the legs will be connected parallel like this. This is the parallel connection. So you need to know, this connection, series and parallel connection, and current will be same in the case of series connection. Similarly, here if we are applying a current I, how this current will be flowing? This current will reach this point, and at this point it has got two paths, one upper path and one lower path. So the current through this R1, current will flow through this R1, and the current also will flow this through R2, and you can say the current will split at this point, and a part of the current will flow through R1 and another part will flow through R2. Okay, these all are the basics, you know that. Okay, so current will split at this point. So let I1 be the current flowing through R1 and I2 will be the current flowing through R2. So total current will be I1 plus I2. So the main point here is that whenever current flows through a series path, the current will be same. Okay, so series connection, current will be same. For parallel connection, the current will split into two paths. So the current will be different. Okay, this is the basic thing. Current will be different in this case. So what about the voltage? In the case of series connection, suppose we are giving a voltage source. So suppose here is a series connection. You can see here voltage source, resistance R and RL. So can you see this resistor R is connected in series to RL. Okay. So this is a series connection. So there is a voltage source V or battery V, and the current will be flowing due to this battery. And what about the nature of the current? The current I will be flowing through this resistance R, and the same current will be flowing through this resistor RL also. Okay. So that is what I said here. Okay. For series connection, current will be same. So Ohm's law is used to find out the voltage drop across a particular component. Suppose we are having the total voltage V and we want to find out the voltage drop across R, and if we want to find out the voltage drop across RL. So what will be the voltage drop across R? You know that is the voltage by Ohm's law, the voltage drop across any component or resistor will be equal to V is equal to I into R. What is the current? That is the voltage drop across resistor will be equal to the current flowing through that resistor into that resistance. Okay. So here you know that here is the resistance R. What is the current flowing through this resistor? This is I. Okay. So we can say the voltage drop across this R is equal to V1. Okay, so let this voltage be V1 and the voltage drop across this R will be V2. Okay, let us find this by using Ohm's law. Since this is a series connection, the current will be same. So we can write Here V1 equal to, what is V1? By Ohm's law, V1 will be equal to current I into R. Current flowing through this resistor, R into current flowing through this resistor into resistance. Okay, so what is that current? I into R. So that is V1. But then what is V2? V2 is current, that is V2 is voltage drop across RL. So V2 will be the current flowing through this RL into that resistance. So what is the current flowing through this resistance RL? That is I. So I into RL. So let us write it, V2 equal to I into RL. So this is the basic thing. Okay, you got the idea? These all are the basics and you might have studied it, but we can go through it. Okay, so this is the Ohm's law and the application of Ohm's law. So this is series circuit. So now we are considering a parallel circuit. Let us see. Suppose we are considering a parallel circuit. Let us draw a parallel network. See, let it be here for reference. Okay. Are you able to see the circuit diagram? Anybody switch on the mic and say, are you able to see the circuit diagram? Nikhil Das. Nikhil Das is there? Can you see the circuit diagram?
Yes.
You can text or mic, you can switch on the mic and you can say the answer. Nikhil Das, are you able to see this?
Yes, ma'am.
Or you can text it. Okay, next is, okay, Nikhil Das. Next is, okay, let it be here. We can compare these circuits, okay? Next is, let us consider a parallel circuit, okay? What is a parallel circuit? Let us take a simple parallel circuit. Suppose two resistors, let it be R1 and the resistor is R2. This is V, this is R1, this is R2. So this is a parallel circuit. So how can you say this parallel circuit? R1 is connected parallel to R2. Okay, R1, one leg of the R1 is connected to this leg of this R2, and the second leg of R1 is connected to second leg of R2. Okay, so this is a parallel connection. This parallel combination of resistors is connected to this voltage source. Okay, so the parallel and series connection you should identify. This is R1 and this is first point and R2 is this one. So this is the first point of R2 and this is the second. So this is a parallel connection, okay? You can say. And in the case of series connection, R1 that means suppose here is a voltage source V, and due to this voltage source a current will be there. Okay, since this is a closed path, there will be a current. Okay, so let the current be I. Let us see. The current be I. Due to this voltage source, let the current coming out of this battery is I. Okay, so what will happen? This current will be flowing through this path. Okay, once it reached this point, what will happen to this current? It see two path. Okay, the current is flowing like this and it will be split into two paths. One path is through R1, other path is through R2. Okay, what is the nature of the current? And can you say how much current flowing through this R1 and how much current flowing through this R2? Suppose here I am telling one thing, that if R1 is greater than R2, what is its meaning? R1 is greater than R2. That is, this resistance is high and this resistance is low. That is its meaning. Okay. So what is the nature of the current? Since R1 is greater than R2, can you say which path will offer low resistance to this current? Here R1 is greater than R2, and which path will offer low resistance to current? Can you say? Can you say? Tell me the answer. Jyotish, see. which path offer low resistance to I? Suppose R1 is greater than R2, and which path? Current will be flowing through this path and it will be split into this path. So which path offer low resistance to this current? Jyotish, see? Can you say? See? Is Jyotish there? Okay, can you say which path will offer low resistance to current? R1 or R2? I am giving the condition R1 is greater than R2. So R2 will offer low resistance. What is its meaning? Then more current will be flowing through this R2, right? Since R2 is lesser than R1, that means resistance is lower for this path and resistance is higher for this path. Since the resistance is lower for this R2, the current will be more current will be flowing through this R2, right? So since the resistance is lesser here, more current will be flowing through this R2. Since resistance is higher, lesser current will be flowing through this R1. So this is the thing, okay? Here, once I reach here, I1 will be flowing through this path and I2 will be flowing through this path. So here I1 will be greater than I2, or if I am giving the notation I1 flowing through this path and I2 flowing through this path, so I1 will be less than I2, okay? So this is the relation, resistance and current. Since resistance is higher, so current will be lower, okay? That point you should remember. And here, we want to find out the voltage drop across this R1 and voltage drop across this R2. See, once we get the current flowing through each branch, we can directly apply the Ohm's law. See, you have the current I1 and you have the current I2. So what is the voltage drop across this R1? So the voltage drop across R1, V1 equal to I1 into R1. Similarly, what is the voltage drop across R2? V2 equal to I2 into R2. See, this is the equation, but you should remember one thing, that since it is a parallel branch, that means this resistor and it has two common points with this resistance R1. So this V1 is the voltage drop across this one, V2 is the voltage drop across this one. Since these are connected in parallel, you should remember that V1 will be equal to V2 because these all are connected in parallel. So V1 will be equal to V2. So this is a parallel case, okay? But in the case of series connection, what is the thing? Current will be same and voltage will be different across each of the component. But in the case of parallel connection, current will be different. So you should, current will be different, but voltage will be same. So that you should remember, okay? We have to apply this simple logic to every circuit that we are going to solve, okay? So this is the basics about the Ohm's law and the application of Ohm's law. Next, we have to go to another law, that is Kirchoff's laws. So let us see what is a Kirchoff's law. Kirchoff's laws. Let us write Kirchoff's laws. Kirchoff's law. Kirchoff's laws, there are two laws, that is Kirchoff's voltage law and Kirchoff's current law. So Kirchoff's voltage law, first law is Kirchoff's voltage law. You can write the notes, Kirchoff's voltage law. Kirchoff's voltage law. We can write it as KVL, Kirchoff's voltage law. So this is Kirchoff's voltage law, okay? KVL, Kirchoff's voltage law. So what is the definition of Kirchoff's voltage law? Kirchoff's voltage law. In simple words, we can say that the algebraic sum of the voltage drop across around a closed path will be equal to 0. That is the Kirchoff's voltage law. You might have studied the definition of Kirchoff's voltage law in your previous semester, but you should remember it. What is Kirchhoff's law? Voltage law? The algebraic sum of the voltage around a closed path or closed loop will be equal to 0. So, suppose we are having a closed circuit path. See, this is R1, this is voltage source, and this is R2, and this is R3. So this is a closed path. You can see this is a closed path because coming from this point, it will go through this and it will be coming to this point. So this is a closed path. So current will be flowing through that path, and Kirchhoff's voltage law states that if we are having a closed path, then the algebraic sum of the voltage drop around the closed path will be 0. So we can write sigma E equal to 0. Or we can say that here what is sigma E? This is V, voltage. V equal to voltage drop across R1. Let V1 is the voltage drop across this. V2 is the voltage drop across this. V3 is the voltage drop across this. So, see, this is the input voltage, okay, DC voltage, and this is the voltage drop across R1. This is the voltage drop across R2. This is the voltage drop across R3. That is V1, V2, V3. You know that in the case of series connection, the voltage drops will be different. So, what is the total voltage drop here? V1 plus V2 plus V3. Okay. Here V is the input voltage. So, we can write it as a V equal to V1 plus V2 plus V3. This is the input voltage. So, whenever a current high due to this voltage source is flowing through this path, some voltage will be drop across this. Okay. So, V1 voltage will be drop across this. V2 voltage will be drop across this. V3 voltage will be drop across this resistor. So, total voltage V equal to sum of individual voltage drop. We can again say we can say this KVL rule in another fashion, like the input source voltage will be equal to the sum of the individual voltage drop across each of the components. So the individual voltage drop is V1 plus, individual voltage drop is V2 plus, individual voltage drop is V3. So total voltage V equal to V1 plus V2 plus V3. So this idea should be clear. Either we can say that V minus V1 plus V2 plus V3 equal to 0. So in these three, we can write it in this manner, okay? Sigma V equal to 0, that is the definition. Or V equal to V1 plus V2 plus V3, that is another definition. Or V minus V1 plus V2 plus V3 equal to 0. So we are taking all these quantity to left side of this equation. So it will be going to like this, okay? So this is the Kirchoff's voltage law, okay? If you are getting a closed path, you can apply this law. Actually, we are simply applying the Ohm's law here. See here, what is V1? V1 will be equal to I1 into R1. What is V2? V2 will be equal to I2 into R2. What is V3? I3 into R3. So we can calculate each of this V1 by using Ohm's law. Okay? By Ohm's law, we can calculate each of this V1, V2 and V3. Then we can simply apply KVL. Okay? So this is the Kirchoff's voltage law. In problems, sometimes you don't have the values of current, but you are having the values of V, R1, R2, R3. So you can find the values of current, okay? And you can then apply Kirchoff's voltage law, okay? So that is Kirchoff's voltage law. That is the first law. Next, there is a Kirchoff's current law. So this is the case of series network. One thing, see. Do you have any doubt? Anybody having doubt? Fatima to Safa. Do you have any doubt? Okay. Are you taking the notes? Are you taking the notes? You should write all these equations. These all are the basics. Once you are coming to the college, I will be taking the rest of the portions. So you should have an idea about all this. Okay. See, next is what is Kirchoff's current law. Okay, next we can take Kirchoff's current law. Kirchoff's current law. See, let this circuit diagram will be here. Then I can compare these two. So Kirchoff's current law. Kirchoff's current law. So Kirchoff's current law. So here, let me first say the definition, okay? Kirchoff's current law. It is regarding the current and it is regarding the voltages in a network. So in the case of current, suppose we are having a common point or common node in a network. So suppose different components, suppose R1, this is R2, and this is R3, and this is R4. How you can say there is a common point or a common node in this network. Suppose there will be different circuit components, like there be a voltage source V1 here, let there be another voltage source V2, like that, whatever it is. So here I am taking a common point where different network elements, actually now here I am taking the different resistors, okay? Different resistors are meeting at a common point, okay? Here you can see the common point. And suppose a current is coming to this point. Suppose this is the incoming current I. A current is flowing to this path. Suppose this meeting junction is A. And whenever this current reaches this point, what will happen to this current? So it will see different path, that is R2, R3 and R4. Either the current can flow through this R2, or it can flow through R3, or it can flow through R4. So that depends upon the values of this resistance. This current can flow to different paths. Okay. If the resistance R2 is very small, then most of the portion of this current I will be flowing through this. If it is the value of R3 is very high, then lesser amount of current flowing through R3. If the value of R4 is intermediate between this R2 and R3, then a medium value of current will be flowing through R4. So we can say that the current will be splitting to different path based on the resistance value or based on the opposing force to this current. Okay. So sometimes if the resistance is high, low current will be flowing through this. Sometimes the resistance is low, then more current will be flowing through this path. So let us denote, let I2 flowing through this path, I3 flowing through this path, and I4 flowing through this path. Okay. So I is the current flowing to this junction, coming to this junction. But you can see the arrow mark is like this. That is, this arrow mark is away. This is coming. Okay. So I is the incoming current. We can say I is the incoming current. I is the incoming current, and I2, I3, and I4 all are going out of that node. So based on this node A, the current I is coming to this node A. But when we are considering this node A, what is the nature of I2? I2 is flowing out of or away from the node A. What is the nature of I3? I3 is flowing away from the node A. What is the nature of I4? I4 is flowing away from A. So I is the incoming current. So I incoming current, and I2, I3, and I4 are outgoing currents. Outgoing currents. So what is? So the I will be splitting to I2, I3, and I4. So if you are applying general mathematical idea, so incoming current will be equal to outgoing current. Incoming current will be equal to outgoing current. Incoming current will be equal to outgoing current. What is the incoming current? So that is I. What is the outgoing current? I2, I3, and I4. So what is incoming current will be equal to sum of, we can say sum of outgoing current, because this current I is splitting to different path. So whatever is coming, that is whatever is coming to this node, that is going out of this node. So incoming current I will be equal to sum of, let me write here, sum of outgoing current. So I will be equal to I2 plus I3 plus I4. Let us see, I will be equal to I2 plus I3 plus I4. So this is the Kirchoff's current law. So this is based on the current flowing through the network. So incoming current will be equal to outgoing current I2 plus I3 plus I4. So this relation you should remember. So This is also called KCL. Once again, here one point, when resistors are connected in series, what is equivalent resistance that I should mention? When resistors are connected in series, suppose R1 and R2 are connected in series. Nikhil Das, can you say the answer? Suppose R1 and R2 are connected in series. What is equivalent resistance? Can you say? What is equivalent resistance? Nikhil Das, are you there? What is the equivalent resistance? You can unmute your mic and say the answer. Suppose R1 and R2 are connected in series. I think Nikhil Das is not there. Okay? You are simply switching on the device and you are going away from the mic. You are not saying anything. Either you can type the answer. See, R1 and R2. Okay, Ashwant, sorry, Ashwant. Ashwant, can you say R1 and R2 are connected in series? R1 and R2 are connected in series. Then what is equivalent resistance? Ashwant, okay. Ashwant is there. And Ashwant, can you say R1 and R2 are connected in series? Then what is the equivalent resistance? See, R1 is connected to R2. So what is the equivalent resistance? Yes, right. R1 plus R2. Nikhil Das is coming now. Where was Nikhil Das? I was asking you many times. Nikhil Das is there. Okay, R1 plus R2 is the equivalent resistance. Okay, it's okay. Nikhil Das, R equivalent is equal to R1 plus R2. And these are connected in parallel. R1 and R2 are connected in parallel. R1 and R2 are connected in parallel. Suppose R1 and R2 are connected in parallel. What is equivalent resistance? What is equivalent resistance? Can you say? Fatimatu Safa. Sorry, Anas Roshan. Anas Roshan. What is equivalent resistance? When R1 and R2 are connected there, what is equivalent resistance? Anas Roshan. Anas Roshan there? Fatimatu Safa, okay. Anas, can you say R1 and R2 are connected in parallel? What is equivalent resistance? Equivalent resistance. That is a simple thing. You should say the answer. R1 and R2 connected in parallel. What is equivalent resistance? You might have studied the relation 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So that is the relation, okay? So 1 by R equivalent equal to 1 by R1 plus 1 by R2. So whenever the resistors are connected in parallel, the equivalent resistance will have the formula 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So what is R equivalent? We can rearrange it. R equivalent will be equal to, you can multiply R1 R2 by R1 plus R2. So actually this is the equation form. So this is the formula and you are simplifying that and you will be getting R equivalent equal to R1 R2 plus R1 plus R2. See, 1 by R equivalent equal to 1 by R1 plus 1 by R2. Let me do it here. R2, we can cross multiply it R2 plus R1 by R1 R2. Okay. So 1 by R equivalent equal to R2 plus R1 divided by R1 R2. Next step, we want to find out R equivalent. So R equivalent will be equal to, you can just find the inverse, that is R1 R2 by R1 plus R2. So this is the basic thing. Suppose the number of resistors are increasing. Suppose instead of R1, R2, R3, R1 instead of R1 and R2, if another resistance is also coming like R1, R2, R3, R4, what is equivalent resistance? Suppose if there are different resistors connected in series, then the total resistance will be equal to the sum of all these resistances. Okay, suppose let me do. Let me say, you should find it. Suppose 5 ohm, 8 ohm, 6 ohm, and then there is a voltage source like this, 6 volt. Find the, you have to do the problem. find the equivalent resistance. Find the equivalent resistance. Find equivalent resistance. Also find total current. Total current. So this is a problem you should do. You 6-volt battery here, 5 ohm resistor here, 8 ohm resistor, then 6 ohm resistor. Okay? And the question is find the equivalent resistance. The next question is also find the total current. You should do it. Okay? What is the answer? First answer, equivalent resistance. Dhyan Biju. What is the equivalent resistance? Dhyan Biju, you should say the answer. What is the equivalent resistance? What is the equivalent resistance? Dhyan Biju. Are you there? Dhyan Biju, are you there? Equivalent resistance is 19. Dhyan Biju is saying that it is equivalent resistance is R equivalent is equal to 19. How will you get? So here 3 resistors, 5 ohm, 8 ohm and 6 ohm. So here 5 ohm is connected in series with 8 ohm. 8 ohm is connected in series with 6 ohm. So equivalent resistance is equal to 5 ohm plus 8 ohm plus 6 ohm. So 19 ohm. So that answer is correct. Dan Biju, answer is correct. 19 ohm. R equivalent is equal to 19 ohm. Next question is also find the total current. So who will say the answer? What is the total current? Fatimatu Safa, what is the total current? What is the total current? Fatimatu Safa, 0.315. Fatimatu Safa, answer is 0.315. What is the unit of that current? What is the unit of that current? Say, unit of current, ampere. Right. So how will you get this current? So current will be, I am asking to find the current, total current. How will you get current? Current is equal to voltage. We can apply the Ohm's law. Okay. So that is the thing you should remember. We can apply Ohm's law. See, this is a series circuit. Okay. Voltage source is there. Resistors are connected in series. So in the case of series network, what is the equation for? We know that Ohm's law is voltage equal to current into resistance. We are asked to find current. So I will be equal to V by R. So total current. So we have to rearrange this Ohm's law. See, V equal to IR is the Ohm's law. And we are asked to find out the current I. So we can rearrange this equation. So current I will be equal to voltage by resistance. So I will be equal to V by R. Okay. So what is voltage? Voltage, you see the circuit, that is 6 volt. So current is equal to 6 by. What is the resistance here? I am simply writing R, but actually this is a network, series network. So the resistance will be the equivalent resistance. So we can write it here as a I equal to V by R equivalent. So I equal to 6 by, what is R equivalent value? We have already find it out. What is R equivalent? R equivalent is 19 ohm. So I equal to 6 by 19 ohm. I am not having the calculator. If you have the calculator, you can just type it. Or 6 by 19 ohm is equal to, she said that it is 0.315. Let me ensure. Is this answer is right? Anybody calculated this value? 6 by 19 ohm? Anas Roshan? Anas Roshan? Anas Roshan is there? Anas Roshan? Are you there? Anas Roshan? If you are not there, yes. Okay, do you get the value? What is the value? I equal to 6 by 19 ohm. Current, what is the value of the current you got? Can you say the answer? Anas Roshan, your answer, tell me your answer. by 19 of okay, it is 0.315. Actually, I asked it to ensure the answer is correct or not. So this is a simple circuit. Similarly, you will be getting different circuits by connecting the resistors in different manner. So you have to apply the Ohm's law or Kirchhoff's voltage law. Whatever easy, you can apply that law. Okay. So this is all the basics, and you can go through the circuit or you can go through the basics. Next class we will be going to different problems. Okay, next class also I will take the review of electronic circuits. Then we can go to our original syllabus. Okay. So let me take the attendance. Are you okay with my class? Is it understandable? Do you have any doubt? Anybody having doubt? Okay, Pranav Raj, Dhyan Biju. If you have any doubt, okay, Kailas. Neha, okay. Okay. If you have any suggestions, let us discuss in the next class. You will be coming to the college, okay? Okay, next let me take the attendance. Wait. Now you can unmute your mic. Let me hear your voice. You can unmute. Roll number 1.
Present, ma'am.
You can say loudly. Roll number 1.
Present, ma'am.
Present, miss. You can say present, miss.
Present, miss.
Roll number 2.
Present, miss.
Roll number 3. Actually,
Miss.
I'm not able to hear your voice. You can type present. Roll number 3. You can
Present.
text. You can text it present, miss. Then only I can take the attendance. I think you are not audible. Hello. Roll number 3. Okay. Anugrah. Roll number 4.
Present, miss.
Who is roll number 4? Roll number 4? I think it is absent.